Hello and welcome to a new episode of the Data Science Daily series. And we are in the Python bootcamp. What we are going to do today is we are going to understand some of the basic operations on the basic data types in Python. So first off, we will start with understanding what are the different operations, the simplest operations in Python. What do they mean? And then we will go into some simple operations you can perform on numbers, right? Remember, there are two data types for numbers. The first one is the integer. The second one is the floating point number. So that's our plan for today. And let's get started without any further ado. If you don't know what data types are, make sure you are watching the last two sessions, which are covering the 8 data types in Python from scratch. And what I will do is I will go over the Jupyter notebook directly today and go through the entire material. So make sure you have Jupyter notebook installed and you have opened it up so that you can follow along with this session. So let me share my screen and let's start it. All right. So this is our plan for today. We'll start with some basic operations, mainly variable assignment. We'll understand what that is, what are some of the rules for variable assignment. Then we will go to converting data types, right? There are different operations that you can perform. And then finally, we will look at what does printing do and what does it do beneath the hood, right? And understand it in a bit of detail. Then we will go into operations on some data types like ints and floats, right? So let's get started with the basic operations first. All right. So let's talk about variable assignment. Variable assignment is used to assign a particular value to a variable. So far, in the last two sessions, when we talked about data types, we didn't really assign a particular object of a data type to a variable as such, right? So we were just using the raw values directly and understanding what are the data types of them. Today, what we will do is we will assign the values to variables, right? And this is called variable assignment formally in Python. And there are a few rules regarding variable names in Python. The first one is that variable names can only contain certain characters. So there are only certain characters that are allowed to be used in variable names. These can be letters, uppercase and lowercase both, right? These can be numbers 0 to 9. And only one special character is allowed, which is the underscore, right? This is the only special character allowed. So these are the characters which are allowed in the variable names. Now, what is not allowed? Let's understand that as well, so that it's crystal clear what kind of a variable name you can use and what kind of a name you cannot use in Python at all. Variables cannot start with numbers. So all the numbers are allowed in the variable name. A variable name cannot start with a number. So that's one. There cannot be spaces in the name, right? You cannot have a variable name with a space between. And we will again see this will not work, right? We'll see with examples. Next, symbols other than the underscore symbol are not allowed, right? And anything other than letters and numbers are also not allowed. This includes exclamation mark, @ hash symbol, $sign, percentage sign, and so on. And these are not allowed in the variable names at all. Right? Python does not allow that. It will throw an error. All right, let's come to one more point, right? The fourth point. Python has some reserved keywords that have special meanings in the programming language itself, such as if, for, or def, which is for defining functions, basically. Now, you cannot assign a variable name which has these keywords directly used, right? So if I say, I want to create a variable called if, it will not work, right? You cannot use these keywords as variable names. So this is another thing to keep in mind. This is the fourth thing that we just discussed. And lastly, it's not a mandatory rule, but the fifth suggestion is that, or the rule is that PEP 8 standards suggest that variable names should be all lowercase. And only if you're using global variables, you should use uppercase variables, or you should have the names in capital letters. Now, why should they be lowercase? Now, this is just, we are referring to PEP 8 standards. And let me click on this and open up the PEP 8 standards, which is talking about naming conventions. Now, it is a way to get the Python code readability to be good, because most of the times you're actually reading Python code, you're not writing that. So the Python code that has been written, it needs to be readable. And PEP 8 is a standard which basically lays down all of these conventions to make it more readable. All right. So what are the naming conventions, right? And this is a very big document. For example, it's saying never use the characters I, right? O, or again, I as single character variable names. In some fonts, these characters are indistinguishable from the numerals 1 and 0. When tempted to use I, use L instead. Right? So it's just talking about some names to avoid. Then it's talking about ASCII compatibility. And then it's talking about some more conventions for package and module names, class names, and so on and so forth. But the idea is to just give you, a sense that there is a convention called the PEP 8 convention, which exists. And this is something you should keep in mind if you want to become a very good Python programmer later on. Make sure you're going through this and you're structuring your Python code with this standard itself. If you start out in the beginning, right, it basically gives some more context. That one of Guido's key insights is that code is read much more often than it is written. The guidelines provided here are intended to improve the readability of code and make it consistent across the wide spectrum of Python code. As PEP 20 says, readability counts. All right. Now let's come back to our operations and let's see some examples of variable assignment. So this is an example of variable assignment, and anything starting with a hash in a Jupyter cell is a command. It's a comment, right? So this is a comment. If I remove this, it will not work, right? It is invalid syntax. So I'm creating a comment by just including an hash symbol in the beginning of that line, right? Because variable assignment is just for me to keep track of the code cell that I'm doing variable assignment here. And I'm assigning a variable called my_int as 11. Right now it has been assigned. So if I simply type my_int, and in MacBook I'm doing Shift Enter. Remember, in Windows you can do Control Enter to directly run the cell. If you want to use the Jupyter interface to run it, you can simply go to the top here and click on Run, and it will run it. Right. So my int has been assigned the value 11. Now let's see what is not allowed. Right. Let's say you will want to create this as exclamation, right? Exclamation my_int, and this is what you want to be your variable name. It will not be able to understand that, right? Even this symbol is not able to understand, right? And a lot of other ones that we discussed, like a $sign, it will not be able to understand that. It's invalid syntax. Basically, Python cannot understand that, cannot process that. However, if you use underscore, it will work, because remember, underscores are usable and they can be in the beginning of the variable name itself as well. Okay, so this is the first one, and we have already looked at this example as well. So this is also not working. Now this is about variable assignment. Let's go into one more basic operation, which is converting data types from one type to another. Now, what I will do in this example is I will create a string first, which contains actually a floating point number within it. But it's a string because it will have the single quotes or the double quotes around it. So I'm creating a string which contains a number in it. And then I will convert that string data type to a number data type, which is a float data type to be particular. And then I will convert it back to a string data type. And then we will see how that's working. So you can convert data types as long as they are compatible. I cannot convert a text into a float because that will not work. And let's see what works first. And then we will go into what doesn't work. You can convert a variable from one data type to another. It's possible, but you cannot always do that, right? It depends. It should be consistent underneath, right? So my_str is equal to single quotations 1.98, and I've assigned the variable my_str as this value. and I'm just calling this on the console. Remember, I'm not printing this. It's kind of showing me the output, but this is different than a print statement, and we will shortly see that. So I'm just calling this variable to see what it holds, and it holds the string. Now, if I check the data type, right, I'm checking the type. I'm performing an operation, which is the type function on my underscore str, which is a variable that now contains this, right? If I hadn't assigned this variable this value, this command, right, type my underscore str will not work. But right now it will work because I've already assigned the value. Now we will see how do you convert the string variable to a float. And what I'm doing is I'm creating a new variable conv underscore str, basically a short form for converted string, is equal to, I'm calling float, right? And within that, I'm calling my underscore str. So float is a function which is used to convert any variable into a floating data type. And float my str will convert the string variable to a float. So my underscore str, right? After the float operation has been performed on top of it, I'm assigning it and putting it into a new variable called conv underscore str. Note that this will not change the underlying variable itself, which is my underscore str. My underscore str will continue to be a string. However, converted underscore str, conv underscore str will now be a float. Right? So I run this and I see that its representation has sort of changed. The quotation marks have disappeared. And now let me check the type of this new variable. Now it's float. And let me make sure that the original variable still is of a string data type, and that holds true, right? So here we have discussed the very basic foundational aspect of writing Python code, where you are assigning variables and then you are performing some, functions and operations on top of those variables, right? And this is how you can build very complex Python code as well. So make sure you're understanding this in a lot of detail. We are going through this very slowly so that everything is crystal clear to you once you are writing Python code. Okay, now let me do one more operation. I have converted a string into a float, right? Or albeit creating a new variable for that float. Now, can I use that float variable and convert it back to another variable with a string, right, of string data type? Let's do that. Conv underscore back underscore str. I'm converting this and saying it's equal to str conv underscore str. Now remember, str function basically will convert any underlying variable value to a string value, right? So what will happen now is, if I do this, I will get back my string, right? You can see that the single quotations are here. Now this has been converted. You have created a new variable, which is now a string, and you have converted this new variable from a float variable, right, by calling the str function. And if I check it, it is now a string, right? And if I check again conv underscore str, that doesn't change. It is the underlying variable. It still remains a float. All right. And if you check if the strings are exactly the same, right? The original string and the string that was first converted to a float and then converted back to a string data type, they're exactly the same. So I'm just calling my underscore str on the left hand side. I'm calling double equal to signs. That is basically trying to compare whether the LHS and the RHS are the same or not. And on the right hand side, I'm giving it the latest string, which has been converted back and forth. And this is true. Now this works. Now let's see some examples of what doesn't work. Let me give you first example of not working, right? If I try to convert, let's say, a float of today is Sunday, will this work? What do you think? No, it will not work. Value error could not convert string to float today is Sunday. It cannot be converted. However, if this was, let's say, a number within it, right, it will work. And it will give me a 0.0 at the end as well. Similarly, let's take another example. let me convert this particular float, right? Underlying it, the number is a float, but it's enclosed within double quotations. So actually, this is a string data type, and I'm trying to convert this to an int. Will this work? No, it will not work, because this underlying value is a float. It is not an int, so it will not work. But if you convert it to a float, it will work. And if you convert something like this to an int, it will also work, right? So whatever is contained within the string, if you're trying to convert it to another data type, basically the value should be compatible with that data type, right? If I make, let's say, a bool of true, it will work. But if I make a bool of capital, right, it again works, right? So this is something to keep in mind. We'll come back to bool actually, right? Let's not look at bool right now. Okay, so this is about converting data types. Now let's come to printing. Printing prints objects onto the console. And how is it different from simply executing a variable in a Jupyter cell, right? The way you have done it before, right? We have called conf underscore back underscore str, and this is the value that we are getting. How is printing this particular variable different? Now, what happens is whenever print function is called, it's basically giving you a human readable representation of that object, right? So underneath, the str function is called regardless of the data type, and then it is sent to the basically the console, right? So str function is for a human readable representation, right? And that's what print is doing. It is creating a human readable representation. However, if when you're simply calling a variable, it's only the REPR, the represent function, which is being called. And this function is basically more suitable for machine code, right? Readability for machines. And it basically creates an unambiguous representation. So it's the exact kind of a value of a variable that the machine understands. So this is the difference between when you call a print statement versus if you just type the variable name and press enter. It will still print the value of that variable onto the console, but that is slightly different from when you use the print statement. So something to keep in mind, right? Let's use the print statement. I'm printing my underscore str, and what this is doing is it's basically first calling the str function and then printing it. And what happens if I just do my underscore str, right? This is what the variable is, right? And you can see that the single quotations are around it. And what this is happening is it is basically calling the REPR function beneath the hood, and this is the same, right? So the represent function, once it's called, print, basically it prints that representation directly. The unambiguous representation is printed. All right. So this is about the print statement. Now we have understood the basic operations that we can do in Python. Let's come to some operations on data types, right? And let's start with integers. It's going to be very simple. Integers are whole numbers. I'm creating a my underscore int variable with the value 11. I can add something to this variable, right? My int plus 1, and Python tells me it is 12. I can subtract something from it. Python tells me it's 10. I can multiply 4, it's 44. I can divide. Notice that I get a float as an output, right? And this functionality is there actually in Python 3 and onwards. Python 2 and all, right? Before this current version of Python, you would not get a floating point number, right? So now Python has basically streamlined this, and if you divide something, you get the exact value out of it. There's an exponent operator where you can do double asterisks, and if you use that, it will basically make it 11 to the power of 3, which is 1331. Now we come to two interesting operators, which is, first one is the float division, where you can use double slashes. It returns the quotient of a division, right? So my int is 11. 11 divided by 3, you can say that the quotient is 9 and remainder is 2. And that's what the floor division is giving you. It's giving the quotient, and the modulo operator is giving you the remainder. Right? So that's what these two operators are. The floor division is double slash, and the modulo operator is the percentage sign. And regarding the floor division and modulo operator, the equation n is equal to d multiplied by n floor division d plus n modulo d is always satisfied. Now n is the numerator and d is the denominator, right? So this is a basic mathematical operation that is always satisfied. Yeah, right? You're multiplying the denominator with the quotient and then adding the remainder. So that will give you the numerator. Okay. Now let's see some more examples of operations, right? So I'm creating another variable my int2, and I can also do kind of these operations, more complex operations, right? And that works. Now we'll look into one more operator, which is the plus equal to operator. And what plus equal to does is it is same as it's saying my int is equal to my int plus 1, right? And this is same as what we saw earlier, which is my int plus equal to 1, right? So plus equal to is basically saying add 1 to my int, but also reassign my int with that new value. So my int becomes my int plus 1, right? This is changing here we are changing the value of my underscore int on the left hand side, because we are assigning the value which is my int plus 1 to that, right? On the right hand side, my int plus 1, right? Let's take this example here. All right, let's take this example here, what we just saw. My int earlier was 10, right? And when you say my int plus equal to 1, sorry, my int was 11. My underscore int was 11. Oh, it has become 12 now. Let's say it is 12, right? Let's start with this and let's again run this particular cell. So my int plus equal to 1 should make it 13. And that's what it is making it, right? How is that happening? First, it is computing the right hand side, where it is saying compute 12 plus 1, which is 13, and then reassign it to this variable called my underscore int. So the value of my underscore int variable is getting reassigned, right? And that becomes 13. Similarly, the minus equal to operator is there, where you can again, this will return 12, right? You're subtracting 1 from the variable and then reassigning that new value to that variable. And then this is the print statement that we just saw. So these are some of the basic operations. Let's see about floats, right? Again, same operations, plus multiplication, division, exponent, right? Then again, the modulo and the floor division operations, very similar, and you can also do complex things here. Notice that there are some places where when my float is 2.1, but when you're raising it to the power of 3, the value should be just 9.261. But it is having all of these zeros as well. So this is a behavior that Python sometimes does, and you need not worry about this, right? So it's giving you a precision, right? And if you count this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So it's giving you a kind of a precision basically, and you don't need to worry about that. That's kind of, you can always round this off to the decimal places. And we'll discuss why this is occurring as well as we move forward. All right. As always, if you have any questions about today's material, feel free to put them in the chat. Today, we covered basic operations on data types, simple data types like integers and floating point numbers. The PDF of today's session will be posted in the comments. So make sure you are looking at that, revising the material, experimenting to get a sense of what are these operations and how do they work. All right, that's it for today. See you tomorrow.